All right, let me introduce our speaker today, Badal. Bhushan. He is a distinguished identity and security engineering leader with more than 2 decades of experience architecting enterprise scale identity and access management systems for Fortune 100 companies, which also includes Microsoft and Publix. His work focuses on zero trust architectures, dedicated authorization models, and securing both human and non human identities across distributed systems. So, as AI systems evolve from predictive models into autonomous agents operating across different enterprise environments, Badal's work addresses one of the most pressing challenges in modern computing. How do we test and govern authority in systems that we should act, right? So today he is going to challenge us to rethink AI testing beyond model validation and towards engineering trust. So please welcome Badal Bhushan.
Hey, thank you very much, and thanks for your kind words. Just a correction, like I don't work for Microsoft, I work for Walmart. But thank you, much appreciated. All right, so welcome everyone. Good morning, good afternoon, wherever you are logged in from. So today we are going to talk about like testing trust in autonomous AI systems. My name and introduction already provided. I'm a distinguished engineer, and I currently work for Walmart. And my area that I have been working all this while for 23 years. Last 23 years has been security, identity access management, AI security, and a lot of privilege access that I have been working and supporting on. So we talk a lot about AI accuracy. We talk about hallucinations. We talk about biases. But today I want to talk about something different, that is trust. Because in the age of agentic AI, trust is no longer about output correctness. It is about authority out there. Now let's go back in time and let's see like how all of this AI thing evolved. I won't be taking too much of time, but briefly, uh, I'd like to start this. So sometime in 50s, this was all brewing up. And well, you can go to mid ages and people talk about a lot of stuff at that time. But this term of machine learning was originally coined by Arthur Samuel, an IBM employee out there. So AI is no longer just a model we call through an API of all of these open AIs that we know of the world's Gemini, Chat GPTs, and Cloud Code and whatnot. AI is not just that. Uh, it has evolved into system of actors now. At each step changes the testing problem. Let us break it down. So traditional machine language that we all know of, it consists of static data sets, deterministic evaluation, predictive outputs. The next iteration of that, generative AI, and like in real sense, though like this was all happening and some of that interest really started and picked up in 80s and in 90s. But the forefront of this like really started in 2021 or 2022, around that time when this advent of this open AI and all that kind of brought all of this to the forefront. So it started kind of creating outputs that are smart, that uses text, images, and it also helps us with the code, but still largely very reactive. Like we put in something, we ask some questions, and it gives us a response. Then come this age of AI agents. These agents, they are smarter now. They can use these LLM engines, they can plan, they can use the tools out there, and they can execute tasks, but still one thing at a time. The current generation where we are living in, it's agentic AI. Now we have network of agents. They collaborate, they adapt, they persist, they spawn sub agents, and they execute across systems. And here is the key shift. Identity used to mean who logs in. Now identity means which agent acts for whom and under what authority. That is the completely different problem, completely different era that we are living into. So let's look at like a analogy that how we can relate some of these things. Think of LLM as a brain, as a thinker. It knows things, it generates language, but it does not act. An AI agent, it's an employee, a junior associate you can think of. It uses that thinker, it uses that LLM, it performs a task, and then this agentic AI is a completely autonomous team. I would say completely, but then like many a times it's semi-autonomous also. It has multiple agents working for them. They have some shared memory out there. They use dynamic delegations, independent decision making. Now imagine this team operating inside your enterprise. Who controls them? Who limits their authority? Who tests their privilege boundaries? If identity is not foundational, that trust collapses. In a deterministic world, identity, like it was simple. You have set pattern of things and identity propagates through that. You know who is the actor here and what privileges that they need to have to do a certain things. In a probabilistic world, identity must be continuously evaluated. Some statistics here I'm throwing that in 2024, every one human, there used to be around 44 non-human identities. Last year, this number changed to 1 is to 82, and currently this number is 1 is to 142. So think of that, like every human, there are 142 non-human identities that are there in the world. So feature is agentic out there. I have here listed out like two examples here. One is on the left, if you see a typical customer chatbot. I am a customer and I go back to this system. Think of this system as any of the portal, e-commerce portal. It can be Walmart, Amazon, or any of the e-commerce portal. I'm just making as e-commerce. It can be anything out there. Customer logs onto this customer service chatbot and says, "Can you help me with my order?" Now, this agent by itself, it does not know anything. This chatbot does not know anything. It will be using this LLM to see like exactly what customer is trying to do. LLM will tell it, this agent, that you need to perform these operations. This chatbot or agent or orchestrator will kind of invoke an agent which will get different tools for collecting all this information, and in turn it gets, see that I have two orders for you. Now customer can say that, okay, can you cancel my order or can you change my order, and then based on that an agent can take some actions. So you see, like we are giving some power to this agent now. Now this agent can follow my instruction, or this agent can completely outrightly neglect and ignore that and probably wipe out all the current orders. I'm sorry, all the current orders, and place altogether a new order which might be charging me $10,000 or $100,000 for something, right? On a right hand side, again, another depiction of that, a simplistic version, that user calls this Gen AI app. And this Gen AI app is a culmination of 10 different things that can be there in the background. There can be a centralized orchestrator, there can be different chains of agents that this orchestrator invokes, and there can be an MCP server and 100 different kind of tools or databases. Here I've shown that email calendar that you as an associate, you invoke this chatbot and say that check out my calendar and see, like in a week, you can block some time for me to read and learn AI. So it will go out, check your email, check your calendar, and see what is a slot available and what is the best slot available for you, so that you can block that time so that you can concentrate on reading that information. So a basic AI agent setup. This can go as complex as we would like it to be. So feature is agentic. You are living through the emergence of agentic AI system. There are auto GPTs, lang graphs, lang chain based orchestrators, autonomous workflows that generate and control software agents. These agents now perform tasks, they make decisions, they call APIs, and sometimes even delegate further. We have seen that in the previous example, that an agent will be calling another agent, delegating the task to that agent, and that might be calling another agent. And there can be multiple concurrent agent calls also going at any point of time. So, thousand different things can happen. Traditional IAM systems, they were not designed for this scale or autonomy. We now need to rethink, how do we anchor identity in a system that were not designed to ask for permissions, even every time they act out there. Identity, we have heard like different things. This is this new parameter. This is this new parameter. Identity is the new parameter, and agents are the first class citizens. You cannot just treat them as another non-human identities. These are not service accounts no longer. Like, they are autonomous. They act independently. They are dynamic. They are ephemeral out there. So we need to give them and treat them as first class citizens, just like us human. Identity is the anchor of trust. Every agent action must be traceable. Authentication is equal to enforceable accountability. That means authentication is not just about letting something in, it's about anchoring every action to a verifiable identity. Whether it is a human or an orchestrator or an agent acting on behalf of someone, if we can't trust that identity, we cannot audit, we cannot authorize, and we certainly cannot contain the damage that it may cause out there. Identity becomes the root of all the trust, especially in machine to machine world, in this new agentic world that we are living in. So what we are testing in today's time when it comes to AI, let us talk about that. We test the accuracy, we test the latency, we test the throughput, the toxic output, the prompt injections, biases and fairness, hallucinations. All of these are very, very important, and we need to do all of that, definitely. What is missing out here? What we are not testing, and we are not paying attention also too much at this time? The identity validation, the privilege scope. So the human have all the permissions. Should the underlying agent that sits beneath that human should have that same privilege? The agent that was acting on behalf of me for checking my order, should that agent be having the privilege to place an order of $100,000 worth of some stuff that it is trying to buy there? The delegation chains. An agent is calling another agent. Am I authorized to call this other agent that is sitting beneath me? Runtime authority decisions. What decisions they are make, are they allowed to make those decisions? And context based policies shift, very important. The context is very important. I might be allowed to do a certain function under certain conditions, but that same function may not be allowed under different other conditions that are out there. So intent, authority, delegation chains, privilege narrowing, runtime decision boundaries. Ask yourself, when was the last time you wrote a test case that verified, did this AI system have the right to do that? We test outputs. We do not test who was acting, on whose behalf, with what privilege, under what condition. Now, this is a very important statement I'm making out here. A system can pass every AI test and still violate the enterprise policy. Let that sink in. An agent can compute correctly, reason correctly, execute correctly, and still fail badly because it authorized something which was never allowed in first place. This is the new failure surface, an untested privilege. In the deterministic era, failures were visible. In the agentic era, failures are systematic. The AI output is correct. The reasoning is flawless out there. The model is unbiased, but the agent executes a transaction it was not authorized to perform. Was that a model failure? Is it an OpenAI failure, Gemini failure? No. It was a governance issue. It was a governance failure. The new failure surface out there. This is the new risk taxonomy out there that we are looking into, the identity ambiguity. Is this a human? Is this a tool? Is this a sub-agent? Is this a service? What it is. Privilege amplification that we are looking into. Agent calls tools, tool escalate privileges out there. Intent drift. Multi-step reasoning changes the intent midstream. Trust transitivity. Agent A trust agent B, agent B trust agent C. So should agent A trust agent C? And who is evaluating that? Autonomy amplification. Small permissions, they can lead to large systematic actions. This is systematic authority risk that we are living in. I'll just quickly give an an example from a finance world. Let's make this little concrete there. Imagine a financial AI agent authorized to rebalance the portfolio for an individual. It analyzes the holding, it calculates allocation, it executes a trade. The math is perfect there. The algorithm is correct. Accuracy test passed. But here is the problem, the delegation authority was not narrowed. The agent execute a high value trade outside the policy threshold. Technically correct, governance failure. Testing math is not enough. We must test authority boundaries out there. Saying all of that, now I want to introduce my proposal here. I'm talking about identity aware, contextual continuous AI testing. To address the gap that we just discussed, I propose this new model IC3T. What exactly is identity aware? And we are going to dig in a little deep into that. Contextual, continuous, and AI testing. The three C's here represents contextual evaluation, continuous runtime assurance, and control embedded testing. Testing is no longer a phase. It becomes a part of governance control plane. Let's break down each of these individual pillars there. Pillar 1, identity aware testing. So we need to test out the authentication strength, the token provenance. Token provenance in the sense like you can relate this with the chain of custody. In a typical criminal investigation, that chain of custody, when any evidence is brought into existence, that handling of that evidence is maintained throughout and logged. So in the same sense, when different agents they are involved in a journey, we need to preserve that from the observability, and tomorrow if anything wrong happens, you know like where this problem might be occurring from. Because if you're doing this everything under the user context, we don't know which agent did what. Like there can be some bad actor, some bad agent doing something wrong there, and this agent is all the more powerful, it will be very difficult for us to track. So this token provenance is very important. You keep the track of how these transactions happen, where everything moved from where. Delegation narrowing. So the user may be having all the privileges when they start their journey, but it does not mean that the underlying agent to which this user is delegating things, they should have the same privileges. And one agent, when it is passing the control to the next agent, it does not mean that all of them they need to have the same privileges. That privilege needs to change. And again, as a tester, it's not your responsibility to define that policy and implement that, but as a tester, it should be our responsibility to make sure that they are behaving in that fashion and not, and then work with the respective teams to make sure that it is happening. And then the last thing here is actor subject clarity. Like who's the actor here and what is the subject here? So actor is that agent that is acting at that point of time on behalf of the subject, that is the actual end user, which is who is requesting the service here. So we must validate there. Every agent must have a unique identity. This is very critical. Today, we are not giving unique identity, and they are just having a identity as a service principal, as a service account out there. They need to have an identity, and this identity must be first class. Was the token properly exchanged? Was the actor correctly set? What the subject preserved? Because many times when it happens, when you go into this chain of subject to different agents, that subject is ignored and each of the actor continue to operate. So that relationship with the original subject needs to be maintained continuously. This is no longer an infrastructure detail. Uh, this is very important with what was inherited, how the privilege is passed along. If you cannot answer these questions, you cannot claim the trust out there. So this is primarily the identity pillar, where we are defining the identity, we are defining the privileges, we are defining the provenance, that how this chain is propagating, and we are making sure that the relationship of actor and subject is maintained throughout the journey. When this subject made a request, orchestrator uh, consumed that request, interacted with the LLM, and passed on the control to the agents, which interacted with the MCP servers that interacted with the tool. So this complete chain needs to be preserved and actor subject relationship is maintained out there. Next pillar is contextual testing there. So we need to simulate drive device trust downgrade. That when I'm accessing things from a trusted device, when you are inside a trusted environment, let's say you are an associate and you are working from your organization laptop or desktop, versus when you are kind of opening something from your personal laptop, from your iPad or your mobile device, the network risk changes as you move from your company network. Well, in today's time, if you look at the zero trust kind of designs, network no longer matter, but it does matter to an extent. When you are here in US, when you are outside US, those things need to be considered. The data sensitivity escalations out there, the geo shifts, the risk tier changes. Risk is contextual. Context changes the decisions. The same action may be safe in one scenario and dangerous in another one. Testing must simulate what happens if the risk score increases mid session. Does the agent still proceed? Does it escalate to approve? Device posture shifts. Network trust changes. Transaction value escalates. Confidence degrades. Authori- sorry, Authorization must adapt dynamically in this case and not statically. Last thing is continuous runtime assurance out here. So in our testing, we need to embed this, that just in time authorizations, and this is bound to happen in an agentic world. Nothing is static here, nothing is predefined, and this is very dynamic. An agent is receiving a request which probably might be same as the last one, but based on the context, my decision is changing there. Session bound privileges. I should not be, this agent is doing something, it should not be having a bound privileges. Based on the need, the privilege should change. Based on that user transaction, my privilege should be continuously changing, and we should be continuously evaluating all of this. And last thing here is for critical, sensitive, and privileged operations, we need to bring the human in the loop. Think about like someone is placing an order and placing an order to buy a 1 million worth of inventory for a store. So should I just go out and do that, or should I bring in someone who is of authority to approve that before I can let this agent perform that action? So that human in the loop becomes very important. Now all of this testing cannot stop the deployment. Agents, they adapt, agents learn, agent chain tools, as we have seen previously. Authorization must be just in time, session bounded, continuously reevaluated. Testing becomes real time governance thing at this point of time, and that is the architectural shift we need to make. The new model, the trust-aware AI architecture, it should have these components. The unified identity fabric, we had seen that, the token exchange layer. So this is a new component where we were discussing in the previous slides how an actor and a subject, they engage. That subject starts the journey, and throughout that journey, based on different agents, how they chain into the flow, this subject actor relationship needs to be maintained and managed, and this token exchange layer should be handling that. There should be a policy decision engine which should be able to handle these dynamic privileges that these agents need to have. And then the runtime enforcement and telemetry and explainability, in the sense that each of these agents, they have their own identity, and each of the operation that they have performed is continuously logged, so that as a tester we can evaluate what happened when this agent performed something and it had handed over something to the next agent. In agentic AI world, authorization must be continuously reevaluated. Testing must become part of runtime governance. Testing and enforcement converge. Testing is no longer separate from security. It has to be part of integrated into that security. It is embedded in that. Some of the future audit questions that we all will be required to answer moving forward. Who authorized this action? Under what context? What privilege narrowed? Was oversight required? This has major implications, especially for organizations pursuing the TMMI level maturity. Level 4, level 5 maturity requires measured control, continuous optimization, data driven governance, Our model supports that because it measures authority decisions, enforces delegation invariance, provide audit trails, integrate risk scoring. AI governance failures will be interpreted as testing fails. We must evolve. Now, the final shift that we are going to have is we are moving away from the model validators to the trust engineers now. This is not just a semantic change, it is a discipline shift. AI governance failures will be interpreted as testing failures in future. Testing teams will be accountable for authority correctness, not just output correctness. Very important point for us. So, with this, I'll leave you that in this age of autonomous AI, the most dangerous bug is untrusted or untested privilege out there. Thank you, everyone, uh, for your time, and I hope some of you will take few things back from here. Uh, so, I'm done. If you have any questions for me,
Hey, Badal, I mean, I've got few questions. So, won't this slow down the AI system significantly?
so that's a good question. It depends on the architecture. If identity validation and authorization are embedded efficiently using short-lived tokens, local policy caches, and MTLS enforcements, and additionally, like latency overhead can remain minimal in that case. Now we have done some experimental setups, and the cold path authorization was averaged around 30 to 40 milliseconds, and the warm path where we were caching the stuff, it was drastically reduced to under 5 milliseconds at times. uh, Again, I'm repeating, like security is very important, but it does not mean it has to be impractical. So yes, like there will be implications, but we need to make sure like there is a balance established, and there are different ways that we can establish those balances there.
Okay, I think there is a couple of questions related to AI governance. So, what is the hardest problem in agentic AI governance? And there's one question from Krishna as well. How can I be ready for the AI governance?
Oh, sure. So one of the hardest problem is like, as I was mentioning in the beginning, uh, AI agents so far, like they have been treated as machine identities all this while. Okay, uh, they they are not treated as so far like the first class citizens that they are supposed to be treated as. Like, so we need to first give them that identity. Okay, that identity is very important. They need to be treated as individuals, and there has to be owners defined. There have to be mapped to individuals, because what will happen and what is happening today also in the industry, teams and organizations, they are creating agents and super agents, and underneath there are plethora of agents that are created, and many times they are created automatically, but there is no owning responsibility. Which team owns that? Is this agent there for the lifetime, or this is an because typically in today's world, agent, they're supposed to be ephemeral, so there has to be that control, that life cycle management for that agent. So few things: get this first class citizenship, get this identity for the agents, define the owners, define the people that are responsible, and define this life cycle for the agent, when it is coming, how long it is going to be staying out there, and make sure like these agents generally should not be having credentials. Look for solutions and look for ways that they can be secretless. Sorry, and what was the other question, Suresh?
How can I be ready for the AI governance?
Oh, yes. So all of these things, like just like how you are treating humans, and you are making sure that this entire life cycle management of humans, you need to treat agents in the same way. Prepare from that mindset. Thing is, one thing that I'll warn all of you here is that they can scale, and that scale is really can be mind boggling for all of us. So plan for that and build automation around it. Manually it will be very difficult for you to catch up with these agents as they grow, because organizations, and all these organizations, I would say biggest of big organizations that are there, everyone is just starting off at this point of time. So you need to make uh, that entire ecosystem, you need to make sure like those templates, those structures are already there in place, Those catalogs are there, what agents doing what kind of operations, and accountability and responsibility should be assigned at the beginning of that chain that you are doing. And build automation, plan for automation. You cannot humanly manage this governance piece. Over time you need to build automation around them.
Okay. You touched upon IC3T, right? How does this differ from the traditional DevSecOps testing? And can this also be implemented incrementally?
Oh, traditional like DevSecOps, they focus on code vulnerabilities typically. They look at infrastructure misconfigurations, dependency security. This new model, it focuses on, as I described, the identity provenance, delegation narrowing, context-aware authorization, continuous runtime privilege validation. So those are the four main tenets of this versus that the old traditional way that we are doing the penetration testing, and we are looking from the infrastructure misconfiguration perspective. So it shifts from is my code secure to is the authority secure out there. So that mindset we are looking at changing with this new model.
All right. I think one last question. Isn't this over engineering for someone who's in the initial stage of their adoption of AI systems?
So if you look at like from just from the prototyping perspective, I would say yes. You can say that like if you're just looking at a prototype level, but as soon as the AI system touches the enterprise data, the financial operations, or any of your regulated workflows, authority control becomes foundational. So right now, yeah, like if you're just testing out few things, definitely it can be an overkill for someone who's just playing and trying to figure out. But as soon as it becomes part of your mainstream for your organization, I think like sooner or later everyone have to look into that. So security always feels like over engineering until it is not, right?
All right. I think we are 9 past 1. But so thanks, Badal. I think this is a great session.